Now, this is a very important point, SAR of the barbiturates. So let us start with the fifth position because this position is required for sedative as well as the hypnotic activity. So some of the substituent present at C5 position, it should be 6 to 10 for optimal hypnotic activity. That means whatever the substituent present at the fifth position, the sum of the both the substituent, the carbon chain, it should be a 6 to 10 carbon chain. It should be that. It is required for optimal hypnotic activity. Next is branch saturated chain. So that means here if branching is there, it is present in Amobarbital as well as the Pentobarbital that increase the lipid solubility. So as we all know that as carbon chain increase is lipophilicity is increased. So due to that, if branching is there at fifth positions of the saturated chain, that increase the lipid solubility and that is produces shorter duration of the actions. Now the sum value at the substituent present at the fifth position, if it is in between 7 to 9, that gives a rapid onset as well as the shorter duration of the actions. 5 to 7, that means it's the intermediate duration of the actions, and the sum value is 4 in case of the barbital. It is a slowest but longer duration of the action. So as we discussed in classification, where barbital where R dash and R2 position, the sum value is a total number of carbon are 4. So it is categorized under the long duration acting barbiturate as a derivative. Next point is branch as well as the cyclic unsaturated chain at C5. That means 5 position, if there is a branching as well as the cyclic unsaturated chain at 5 position, that reduce the duration of action due to the increase in metabolic conversion to a more polar as well as the inactive metabolite. Now greater branching at fifth positions, more potent will be the drug. Hence pentobarbital is more potent than amobarbital. So here the structures are there. This is a pentobarbital, this is a amobarbital. So if you look at the structure of the pentobarbital, where here there is a methyl groups, in amobarbital methyl group present at the terminal end of the carbon chain. So here there is a more branching. So as branching is increased, the more potent will be the drugs. Within the same series, allyl, alkenyl and cycloalkenyl may result in greater potency than same number of the saturated analogs. That means 6 carbon chain and cyclohexane. So cyclohexane, if it is substituted at fifth position, that will produce great effect compared to the its open chain analogs. Alicyclic and aromatic substituted barbiturates are more potent than aliphatic analogs with same number of the carbon. Next is introduction of the halogen at fifth position, that increase the potency. Introduction of some polar substituent like hydroxy, amino, carboxylic acid, carbonyl carbon, amines group, sulfonic acid group into the aromatic ring at fifth positions, that result in decrease the lipid solubility as well as the potency. Alkylation at 1 and 3 position, that means these positions. Okay. Pyrimidine rings nitrogen, if it is alkylated, that produce the shorter onset and duration of the actions, shorter duration of the action compound. Replacement of the second keto with the sulfur at second positions, that increase the CNS depressant activity and which is categorized under ultra short acting barbiturate derivative with decrease in polarity, and this is all are the ultra short acting barbiturate. And same with fourth number and sixth number of the keto group, if it is replaced by sulfur or any other heteroatom, that is decrease the hypnotic activity. So this is a very important SAR for your routine examination for various competitive examinations. So fifth positions of the SAR, that is a more important for sedative and hypnotic.